welcome to Edu Idea. Great ideas come from great teachers.
Hey guys, so for today, we're going to learn about probability in terms of calculating probability using tree diagram and also tables. Okay, so let's begin with the tree diagram, and I'm gonna show you the example on how to use the tree diagram to calculate probability. Okay, so this is the example. So let's say we have two coins are tossed once. What is the probability that question A is getting both head, and question B is getting one head and one tail, and then question C is getting at least one tail? Okay, so we can use tree diagram to calculate the probability. So let's draw the tree diagram. So because we have more than one object, which is two coins in here, so we need to see it from like each of the coins. Okay, so let's say we have the first coin. We know that the first coin, right, the first coin has two sides, the head and the tail, right? So we're going to make a tree diagram, and then head and then tail. We know that the probability of getting a head is 1/2, and the tail also 1/2, right? Because we have one head out of two sides and one tail out of two sides, so both of them will be 1/2. Okay, so this is from the first coin. So the second coin will be also the same thing, head and tail, but we don't just like we need to make another branch from each of the branch, right? So we do it like this: from the head, from the first coin, the second coin can be head or it can be tail, right? And we know that the probability is 1/2 for each of them, right? So yeah, and the same thing with the tail, right? So the same thing, if we get tail for the first coin, we will, I mean, like, the possibility of getting we can have head or tail on the second the coin, right? The second coin. So head and tail, right? So which means that we have this tree diagram in order to know, if we toss these two coins, what is the probability of getting like head head, head tail, tail head, or tail tail. Okay, so we have that. The first one is head head. Notice the branch, right? The line, and then the second one is head tail, and then the next one is tail head, and the last one is tail tail, right? So question: how can we find how can we calculate the probability? So as you can see that we have wrote the probability, right? So for this guy is 1/2, and this is 1/2. So for this branch, right, head head is 1/2, 1/2. So remember that, guys. The logic is like this: if you add these two numbers, right, you will get 1. 1 is a certain event, but this is not certain, because you can have head head, you can have head tail, you can have tail head, or you can have tail tail, right? So instead of like adding the numbers, the probability, you multiply it, because we know that whenever it has more object, the chances are getting lower. Okay, so you multiply those two numbers. So 1/2 times over 2 is equals to 1/4. 1/4, yeah. And the same thing with the head and tail, right? So we have this branch over here, right? So it's 1/2 times 1/2 equals to 1/4. So it happens to be all of the numbers are the same. Yeah, it happens to be coincidentally all of them are the same. So which means that we can write down all of the probability equals to 1/4. So the chances of you getting a head head, the first coin is head, the second coin is head, is 1/4. The first coin is head, and the second coin is tail, is 1/4, and so on, so on, so on. Yeah. So from this diagram, we can answer the question that we have here. Okay. So the first one is getting both head. Both head means it's going to be head and head, right? Head and head is this guy, and the probability is 1/4. Right. Okay. So head head means both head. So probability of getting both head is equals to 1/4. Okay. Simple as that. So the next one is getting one head and one tail. Okay, getting one head and one tail. One head and one tail can be like, we have two of those. We have HT and TH. Both of these is one head and one tail. It doesn't matter which one is head, which coin is head, which one is tail. as long as you have one head and one tail, right? So you have these two possibilities, right? So this guy and this guy, because those two have one head and one tail, right? So in here we have this guy is 1/4 and this guy is 1/4. So which means that we add those two numbers. If it's like or, right? So getting a one head and one tail, right? So you add the probability, right? So if you want to know, for example, getting both head and or like sorry, getting head or tail, so you only need to add these probabilities. So notice that if I add all of these, right, 1/4 plus 1/4 plus 1/4 plus 1/4 is equals to 1, right? So 1 is a certain event. So notice that every time you have all of these number here, no matter how the tree diagram is, it will always be equals to 1 if you add it. So yeah. Last one is getting at least one tail. So at least one tail means that you can have one tail or you can have two tails, right? So at least one head can be a head tail or tail head or tail tail. You cannot have this one because this one doesn't have any tail, right? It's head. So this does not include. So the one that you see is this guy, and this guy, right? So these three. So you add all of these numbers here. So 1/4 plus 1/4 plus 1/4 equals to 3/4. Okay, so this is how you use the tree diagram. Okay, second example, 6 red and 9 blue marbles in a container is taken twice, one by one without replacement. So you have this 6 red and 9 blue marbles in a container, and you take two, right? Two marbles one by one without replacement. So after you get one marbles, you don't put it back. You take another one from the container. Okay, so the question is, what is the probability that getting both of red? So you take the one and then the first marble and then the second marble you take, both of them are red. Or another question, getting one red and one blue, and then getting at least one blue. And yeah, these are the question that we're going to answer. Okay, so let's go for the first question, which is getting both red. But because we in this topic we're going to use the tree diagram, so we do the same thing like before for the coin, right? So like the first marble that you take and the second marble that you take. Okay, so the first marble will have something like this. Okay, so the red is, and then the blue, and then and then red and blue, because we only have two. And then we have the probability of getting red and getting blue for the first time you take the marbles. Okay, so this comes from the 6/15 comes from because we have 6 red, and the total, right, the total of marbles is equals to 6 plus 9. So 6 plus 9 we have equals to 15. So that's why we have 15 as the denominator for the probability. Okay, so that's the first one. The same thing with the blue one, right? So the blue one is 9/15. The 9 comes from here because we have 9 blue, and this 15 is from the total of the marbles that we have inside the container. Okay, so that is for the first one. Okay, that is for the first marble you take. Okay, now let's go to the second marble that you take. Remember that you did not put the marble that you took for the first time, and you take another one without putting back the one that you've already taken. Okay, so in here we have the second time you take the marbles, and the tree diagram will be like this, because we know that we have red as the first marbles that you take. The second marble could be red or could be blue, but what is the probability for each of them? Okay, so let's go from the red first. The red will be 5/14. Okay, so question, why is it 5/14? The 5, because in this branch here, right, you have considered that you have red, you have taken the red, right? You have taken red marbles on your first try. Because you don't put it back, it means that the red will not be 6 anymore, it will be 5, right? Because it's reduced by 1, because you have taken it. And the same thing with this 14, because in total we have 15, right? In total we have 15 marbles previously, and because we have taken 1 marbles without putting it back, so the second time you take the marbles will not be 15 anymore, it will be 14, because you reduce it by 1, because you have already taken it, right? So that is for the red. Okay. Okay, the next one is the blue one, right? So I noticed that you can guess it, right? So how many blue that we have if we if we focus on this branch, right? For the first time you take the marbles, the first time you took the marble, you get red. Okay. Question: how many blue left? It's still 9, right? Because you didn't take any red. You didn't take any blue here, right? So the chances or the probability of getting a blue is 9 over 14. Again, where does this 9 come from? Is from here. And since from this branch you didn't take any blue, so the blue, right, is not reduced. So it's still 9. We still have 9 blue for this branch, yeah. And again, we have this 14 because we have already taken 1 marble from the first time you took the marble, yeah. Okay, now let's go to the next one. Okay, so the branch on the blue one, right? So the branch here, the first one is again red. And okay, so in here, guys, notice that in this branch, for the first time you take the marble, you get blue. So which means that the red is still the same. The number of the number of red marbles here are still the same, which is equals to 6. And since we have taken 1 marbles from the first time you take it, so that will be 6 over 14. Okay, so again, the 6 comes from here because in this branch the red hasn't been taken yet, so it's still 6. We still have 6 red. And for 14 here, because we have already taken 1 marbles, so the 15 reduced by 1, you get 14. Yeah. Okay, so the same thing with the last one, the last branch here, the blue one, because we know that we have taken 1 blue, right? We have taken 1 blue in here, so which means that the blue will be reduced by 1, so that will be 8, right? 9 minus 1 is equals to 8. And that will be 8 over 14. Again, the 14 comes from, you have taken 1 marble from the previous one, so it's 8 over 14. Okay? So, we can make something like before, like the coin, right? So, let's write that down, okay? So, RR means like you get both red and red. For the first time, you get red. Second time, you get red. And then you only need to multiply the numbers here because it's the branch, the 6 over 15 multiply by, so I'm going to use highlighter, so 6 over 15 multiplied by 5 over 14 because the red is on that side of the, what do you call it, the branch, yeah? Just see the branch, yeah, guys. Let me use my pen. Okay, so this branch over here, right, is this guy and this guy, multiple that, you get this, okay? You can use a calculator if you're having difficulties in multiplying the fraction, it doesn't matter, okay? The same thing with the next one, which is the red-blue, right? The first time you take it, you get red. The second time is getting blue, so you get 6 over 15 multiplied by 9 over 14, and you'll get that number, okay? And the same thing with the others, okay? You do same thing. Okay. So with this diagram, with this third diagram, we can answer the question. Okay, so let's go and see the first question. Getting both red. Getting both red means it's RR, right? This guy, right? So RR is 1 over 7. So yeah, so P A means like an event in here, like both red. You can actually write down anything in here, right? So for example, if I write down event A is getting both red, right? So you can write down just A inside in here. You don't need to write down both red for the letters, the words inside the bracket. So just you can use like a capital letter in here. Yeah. Okay, quite easy, right? And then the same thing with the next one is getting 1 red and 1 blue, right? Getting 1 red and 1 blue are these two, right? Red blue or blue red. But again, it doesn't matter which one goes first. Is it red first or blue first? The question is just getting 1 red and 1 blue. It doesn't tell you specifically whether you need to have red on the first try and second blue on the second try, and so on, so on. So because it doesn't have any information about that, it means that it doesn't matter with the order, right? So again, if we have like two of these, so what we need to do is only need to add those two numbers, those two probabilities, which is 9 over 35 added with 9 over 35, and that will be equals to 18 over 35. Yeah, okay. And the last one, getting at least one blue. At least one blue means that you get these three possibilities, right? So RB, BR, or BB. So all of them have one or two blues because it said at least one blue. So again, you only need to add all of the probability. 9 over 35 plus 9 over 35 plus 12 over 35 equals to 30 over 35. Or you can simplify that equals to 6 over 7. Okay, the next one is using table to find probabilities. Okay, so this is the example. Okay, example 1. Two dice I bring to once. What is the probability that getting a total of 3, getting at least a total of 10, and getting a total of less than 5? So actually we can use the tree diagram, but for this one we're not going to use that because you'll have a lot of branches, because we know that in a dice, right, a normal dice, a die, I mean, like, it has 6, right? It has 6 branch, like 1 2 3 4 5 6, and then we have another because we have 2 object, and then which both of them are dice, and which means that we'll have like 6 branches, like for the first die, and the second die will be have like 6 branches for each branches, so you will have a lot of branches there. So instead of using that, we can use table. Okay, so I'm gonna show you the table. Here we go. So let's say we have 2 different die. I mean, like 2 of the same shape, but the only difference is like the color. The first one is white die, the second one is red die. Okay, so we know that the white die, we know that both of the die, right, has a number of 1 until 6, 1 2 3 4 5 6, and the second die is also the same, 1 2 3 4 5 6. So we have this table here to match for each of the possibilities. For example, like this guy over here, so 1, 1, what is that? So which means that for that one is you get 1 on the white die and you get 1 also on the red die. So if I draw it, you will get like 1 on the first die, and then you get also 1 on the second die, right? This 2 1, what does that mean? It means that if you get 2 on the first die, and then you get 1 on the second die, right? And so on, so on, so on, until you get 6, 6, means that you get 6 on the first die and 6 on the second die. So this is a much simpler way on how to draw an illustration on how probability works. Okay, so here we go. So remember that the probability of an event A, for example, is equals to the number of event, like the total number of event that can happen for event A, and then over the total of the sample. S means sample. Sample means like all of the possibilities. Now we need to know how many possibilities here, right? So we know that there are a total of 36 outcomes, right? So and S, so the total number of the sampling, or the total number of like the outcomes, will be equals to 36. So where do we get the 36? So actually, guys, it's as simple as you find an area of a shape, a 2-dimensional shape, right? So it means, for example, like you have like a rectangle, for example, like this 3 and this is 5. You only need to multiply these two numbers, like 3 times 5 is equals 15, right? So the same thing with this guy here, the table. We can just like multiply the number of column and the number of line that we have in here. So we know that we have 6 here, right? So we have 6 in here, and we have 6 in here, right? 6 times 6 equals to 36. Okay, so this is one of the way on how to find the total outcomes when it comes to table. Okay, so in here, the first question is getting a total of 3. Okay, getting a total of 3. So what does that mean? It means that if you add the two numbers on the white die and on the red die, you will get a total of 3, right? So where do we get in which of these pairs we get 3 from adding both of the numbers? Okay, so we get it from here, and also we get it from here, right? So as you can see, you cannot have anything, any other possibilities, right? Only 1, 2, 2, 1, and 1, 2, because 2 plus 1 is 3, and 1 plus 2 is equals to 3, also the same thing, right? If you don't have any other possibilities, for example, if I take this one, that will be 6, right? Because 3 plus 3 is equals to 6. The one that you the one you will get a total of 3, only those two possibilities, that one and the other one, because we know that we have only 2, right? So 2, 1 and 1, 2 are the possibilities of getting a total of 3. So an A, so the total number of event for event A, right? Event A is getting a total of 3 for this question. So because we know that NA is equal to 2, so you only need to put that into the formula. So NA is 2 and NS is 36. So it's 2 over 36, or you simplify that, equals to 1 over 18. Okay, the next one is getting at least a total of 10. At least man, it can be 10, or it can be more than 10, like 10, 11, 12, 13, and so on and so on. Okay, so again, as you can see here, guys, let's see the samples, in the table, right? Where can you get 10 from these three, right? 4, 6, 4 plus 6 is 10. 5, 5, this guy, 5 plus 5 is 10, and 6 plus 4 is also equals to 10, right? So these three are the possibilities of you getting a 10. But again, guys, it said at least a total of 10. Means that you can have more than that, right? It can be 11 or it can be 12. So let's go to the next number, which is 11, right? So 11, we get it from here. We have 5, 6, and 6, 5, because 5 plus 6 is 11, and 6 plus 5 is 11, and it is more than 10, right? And last one, this guy is 6, 6 equals to 12. 6 plus 6 equals to 12. And we cannot have any other samples in here in which you will get at least of 10. So how many do we have in here? 1, 2, 3, 4, 5, 6. So we have 6 samples, right? So an A will be equals to, because it's B, question B, yeah? So it's NB. Yeah, and B is equals to 6, because we have 1, 2, 3, 4, 5, 6 of that. So 6. And the total of outcome is still 36. Yeah, so it's 6 over 36, or simplify that, equals to 1 over 6. Okay, the last one, getting a total of less than 6. Okay, less than 6 means that 6 doesn't include. Yeah, 6 doesn't include. So we will start from 5, because it's less than 6. So to get 5, we get from these numbers, right? 1, 4, 2, 3, 3, 2, 4, 1, because 1 plus 4 is 5, 2 plus 3 is 5, right? 3 plus 2 is 5, 4 plus 1 is also equals to 5. And again, because it's less than, means that we can have less than that, okay? It can be 5, it can be 4, it can be 3, it can be 2, it can be 1, it can be 0, or it can be negative. But in this case, guys, the smallest number will be 2, because this is the smallest number, right? So it can be 5, 4, 3, and 2. Okay, so as you can see that this guy here, 1, 3, 2, 2, 3, 1, and 1, 2, 2, 1, and 1, 1, all of them, if you add them together for each of the samples, you will get a total less than 6, right? So again, it's the same thing, because we know that there are 10 possibilities of 10 possibilities of getting a total of less than 6. So the n of C, because this is question C, right, in this case, so equals to 10, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the total outcome should always be 36 for this case. So 10 over 36, you can simplify that, becomes 5 over 18.